So, let's talk about AI forecasting. We've got these incredibly powerful models, right? But what if I told you there's a hidden flaw? A flaw that can make our best AI forecasters totally unreliable. It's a really subtle issue, but the consequences? They are absolutely massive.
All right, let me throw a question at you, and it's going to sound a bit like a riddle. Can an AI be perfectly accurate and at the exact same time be perfectly useless? I know, it sounds impossible, right? But this paradox is actually at the heart of a huge challenge we're facing in long-term forecasting.
Okay, let's make this real. Imagine you're in charge of a city's power budget. It's March. You ask your fancy AI what energy use will look like in August, and it says, high, really high. So you start making plans, buying power, scheduling maintenance. Then April rolls around. You run the exact same AI with the new data, and now it says, oh wait, actually August is going to be low. Now here's the kicker. Both predictions were technically accurate based on the information they had at the time. But for you, your plans are a total mess. This isn't just a thought experiment. This kind of chaos is a real headache for industries all over the world.
So, this whole mess has a name. Researchers call it the output alignment problem. It sounds kind of technical, but all it really means is that the AI just can't agree with itself. So what is the output alignment problem? Well, it's when an AI model can't give you a stable prediction for the same point in the future. You feed it a little bit of new data, and suddenly its entire long-term forecast flips on its head. It's like the model gets way too focused on the latest news and forgets the bigger picture. And that instability, that wild swinging back and forth, that's what makes it completely unreliable when you're trying to make important decisions.
And without a way to fix this, what you get is just chaos. The predictions for a single future date are all over the place, like a tangled mess of spaghetti. This is what that inconsistency actually looks like. And you've got to ask yourself, how can you trust a system that's constantly changing its mind like that? You just can't.
And this isn't just an academic problem. The real-world costs are huge. You're talking about tons of wasted money because companies have to keep changing their plans. It totally destroys any trust you might have in the AI. I mean, if the forecast is different every single week, you're just going to start ignoring it, right? It pushes people to make bad, irrational decisions and miss out on huge opportunities. So the big takeaway here is that accuracy isn't the whole story, not even close. What we really need is consistency.
Okay, so if consistency is the goal, that brings up a pretty big question. How do you actually measure it? You can't fix a problem if you can't even tell how bad it is.
This is where we see a massive blind spot in the way we used to do things. Think about our old metrics, stuff like mean squared error. They were all asking just one question. How close is my prediction to the actual outcome? They were obsessed with accuracy. And that's fine, but they were completely blind to this whole consistency issue. It's like judging a singer only on hitting the final note, not on whether the rest of the song was in tune. So researchers needed a new yardstick, one that asks a totally different question. Forget the final truth for a second. How close are your predictions to each other?
And that new metric has a name, the Time Alignment Metric, or TAM for short. It's really the first tool ever built specifically to measure this idea of consistency or alignment between all the different forecasts for the same future date. And all you need to remember is this. With TAM, a lower score is better. A low score means high consistency. The predictions are stable.
All right, so we've got the problem, and we've got a way to measure it. So what's the fix? Well, let's talk about the solution. It's a really cool new method called ALIO, which is short for aligning outputs.
ALIO is all about creating harmony, and it does this in two really smart ways. First, it aligns things in the time domain. That just means it looks at two different predictions for the same period and literally pushes them closer together. But then, and this is cool, it also aligns them in the frequency domain. Think of this like tuning an orchestra. It's not just about the notes, it's about making sure the underlying rhythms, the cycles, the patterns in the data are all in sync.
Okay, but here's the million-dollar question. How do you force predictions to be more consistent without accidentally making them, worse? This is the truly brilliant part of ALIO. It uses a clever trick called regression polling, or regpoll. For any two clashing predictions, it first figures out which one is actually closer to the ground truth right now. Then, it gently pulls the worst prediction towards the better one. It's an incredibly smart way to make the predictions agree with each other while also nudging them all towards a more accurate answer.
And here's maybe the best part, especially if you're a developer or a business using these models. Alio isn't some brand new, complicated model you have to build from the ground up. Nope. It's designed to be plug and play. You can take the state-of-the-art model you're already using and just add Alio into the training process. That's it. No need to tear apart your existing architecture. It's a simple, elegant add-on.
So the theory is fantastic, but does it actually work in the real world? Well, let's look at the proof. The researchers really put Alio through its paces.
Well, let's start with consistency. When they bolted Alio onto existing models, the results were just dramatic. That TAM score we talked about, it improved by as much as 58.2%. That is a huge drop in the chaos. It's basically turning a noisy, confusing mess into a clean, clear signal.
Okay, so that's an incredible win for making these models more reliable. But remember that regression polling idea? The whole point was to improve consistency without sacrificing accuracy. So, the big question is, did it work? What happened to the old school accuracy score?
Get this, the accuracy got better too, a lot better. The error rate dropped by up to 27.5%. And this is the real magic of Alio. It turns out by forcing a model to be more consistent with its own past predictions, you also force it to become more accurate overall. It's the ultimate win-win. You're hitting two birds with one stone.
The numbers are one thing, but seeing it really drives the point home. So, take a look at a typical model before Alio. Every time new data comes in, the forecast for the future just jumps all over the place. It's that tangled, chaotic mess we were talking about. You can't plan around that. It's useless.
And now, look what happens after you apply Alio. It's night and day. The predictions just snap into this beautiful, clean alignment. They move together in this tight, coherent band. That is what a trustworthy, reliable AI forecast is supposed to look like. It's stable, it's consistent, it's something you can actually use to make real decisions.
So, as you can see, this is way more than just some minor technical fix. This really points to a bigger shift in how we think about AI. We're moving past the point where we only care about accuracy. Now, we're demanding true reliability.
And why does this shift matter so much? Well, think about the really big stuff. Managing our power grids, predicting climate change, planning for the next pandemic, or trying to forecast financial markets. In these high-stakes games, having one stable, reliable forecast is worth so much more than a dozen perfectly accurate ones that are all telling you different things. This kind of consistency is what lets us actually plan for the future with some level of confidence.
And really, it all comes down to this idea. If AI is going to truly help us in these critical fields, it can't just be smart. It has to be dependable. It has to be a partner we can actually count on.
So, we figured out how to teach AI to be not just accurate, but also consistent. That feels like a huge step forward, and it really makes you wonder, what's next? What's the next big quality we need to build into these systems to make them truly trustworthy partners for humanity? Definitely something to chew on.